So in this video, we're going to be going over Pascal's triangle and how to apply it to expand binomial expressions. So let me go ahead and look at the questions here. All right, the first thing that I'm going to do is I'm actually going to draw out Pascal's triangle. Now it's kind of cool because it's named after a French mathematician named Blaise Pascal. He also made contributions to physics and philosophy. Okay, if you're interested in his philosophical works, you can read his book Pensée, which in Latin means thinking. So these are like his meditations. Well, anyway, he's known in Algebra 2 for providing us with this great formula, or sorry, this diagram. And well, I'm going to go ahead and write it out. So the first one, you write a 1, and then you put a 1 and then a 1 like that with a space. Then you have 1, and then you add these 2, you write it down, and then you put a 1 over here. And then I'm basically expanding out Pascal's triangle. So you always add these 2 right here. So 1 plus 2 is 3, and then you kind of write it like in between, but on that line. And then 2 plus 1 is 3, and then you're left with a 1. So you're always going to have 1s at the edge. And I'll go ahead and expand another row over here. So that's 3 plus 1 is 4. 3 and 3 is 6, and then 3 and 1 is 4, and then 1 right here. Okay, so this can keep on going as much as you want. It could be, you can have a million rows, a billion rows, whatever you like. What's important is what each row represents. So the first row corresponds to n equals 0. Now, you might be talking about, you might ask, what in the world do we mean? What do you mean n equals 0? Well, we're talking about the exponent of a binomial. So let's say you have a plus b, and this is to the power of 2. So the exponent here is 2. That corresponds to the row that's n equals 2. So real quick, just to justify this, you might be wondering, how come you just have 1 when you have n equals 0? Well, we can imagine that. So let's write a plus b to the power of 0. Remember, anything to the power of 0 is always going to be 1. So you're saying this whole thing is to the power of 0, which means all of it is just 1. So we're left with just 1. The second row corresponds to n equals 1. So you'll be using these coefficients when you have 1 as your exponent. The third row corresponds to n equals 2. Then the fourth row, n equals 3. Fifth row, n equals 4. Okay, and so on and so forth. So how do we use this triangle? Well, I'm going to make up a simple example just to kind of show you what's going on here. These numbers represent the coefficients that you multiply your terms by. So let's do an example where it's n equals 2, just so you can kind of see how it works. So we can write x plus 3. I'm just coming up with a random example. So x plus 3, and we're going to use n equals 2. So it's x plus 3 squared. Okay. So the coefficients that we're going to be working with are 1, 2, and 1. So what I would recommend is you can put equals, and then you're going to write these coefficients out. So you don't have to always do that, but I'm just doing this at the beginning just so you can see what's going on. Now, here comes like a little trick here. What you're going to write next to that coefficient, so it's going to be multiplied by, and then multiplied by. You have to start with, you're going to be writing products of these two terms of x and 3. So you have to be very careful. The first one I'm going to write down is 3 times x, but you have to be very careful because the one right here, right, this first one, x, he's gonna start off with the biggest exponent. Our biggest exponent here is 2, right? So it's gonna be x squared because that's the biggest one. And then the second guy, where you have this plus 3, the second one is going to be an exponent of 0. Okay? So that pattern will always be reproduced. So the second thing in your binomial, the second term, when you write it for the first term, when you expand it, right, when you write it here, its exponent will be 0. The first one, his exponent is 2 because that's the biggest one here. And we're going to go in an increasing order for the 3, meaning the second guy here, and a decreasing order for the first term here that ends up on this side. So that 2 is going to be 1 in the next one. And the exponent here is going to be 1 as well in the next one. So this takes care of our first term. Then we put a plus sign. And then now we have that 2 again comes from Pascal's triangle. So that's right here. So that 2, we're going to multiply it by 3. But this is, notice that 3 was to the power of 0 here. Now it's going to be 3 to the power of 1. And then I'm going to write x. This is x squared, so this one's decreasing. So this is now going to be x to the power of 1. Okay, so we got that. And then plus, finally over here we have 1 times. And then again I'm going to put a 3 and an x. Now remember, our 3, this guy, his exponents are increasing, right? So 0, 1, now it's going to be squared. And then the x, his exponents were decreasing. So it's 2, 1, now it's going to be 0. So we have this expression here. What we need to do now is we need to simplify all of these, each term that we have. Let's simplify it. So this is saying 1 times 3 to the power of 0 is 1, right? So 1 times 1 is 1, so that goes away. And you're left with x squared. Then here you have 2 times 3 to the power of 1. Well, that is 6. So I'm going to write that. And then this is just x to the power of 1, so I can just write it as x. And then over here, we're going to add 1 times 3 squared. Well, 3 squared is 9 times 1 is 9. I put a 9 there. And then x to the power of 0 is 1. So 9 times 1 is 9, so it stays like that. And then you're officially finished. So this is the expansion of that binomial. Okay. So Pascal's triangle, it might seem trivial at first. And let me explain why. If you're looking at x plus 3 squared, this seems like, oh, well, you can just write it like this, right? And then do FOIL and all that you learned in Algebra 1. Yeah, that's pretty easy, right? So it might be easier to do that than Pascal's triangle for something like this. But if you get a binomial that's like x plus 5 to the power of 10, can you imagine, right? You would have to write this out 10 times, right? X plus 5 times x plus 5 times x plus 5 times x plus, right? 10 times, and then you would be distributing over and over and over and over, and it would just take way too long, right? So once the exponents start getting really big, right, it becomes easier to use Pascal's triangle. So that's why you learn it, because especially when you get to Calculus 2, you'll be working with sequences and series and infinite series, and you will be using Pascal's triangle to expand some infinite series. But anyway, back to this. So let's go ahead and look at one of the questions here that you have. So you're looking at number 2 in that picture that says g minus 2 to the power of 4. So let's go ahead and write that out. So g minus 2 to the power of 4. So we're going to be expanding this using Pascal's triangle. So the first thing I'm going to do is look at the triangle, see if we have 4 here. So because it's saying g minus 2 to the power of 4, so we have to look at that one, which is the 5th row, right? Don't get this confused. The first one represents n equals 0. We want to look at the n equals 4, which is the 5th row down, right? 1, 2, 3, 4, 5. Yes, so this guy. That's when n equals 4. These are going to be the coefficients that we're going to multiply with. So let me go ahead and write it out here. So I'm going to put a 1 and then a big space, and then I'll put 4 and then a space, 6, a space, 4, a space, 1. Okay. Now we're going to go ahead and write these guys right here. Now you have to be extremely careful because Pascal's triangle is in the form of a plus b, right? So if you see a minus 2, that you're going to treat as a negative because this is saying g plus negative 2 to the power of 4. So just be careful with that because there is a minus, so that's really going to be g plus negative 2. Okay, so we can go ahead and write these out. So I'm going to put the number in front. So That's negative 2, so I'll write it here, with parentheses, of course. Remember the second one, it starts off at 0, the exponent. So that's negative 2 to the power of 0. And then we have times g to the power of 4, because you always start with that exponent, that number that you're given here. And then the g's will be decreasing, the negative 2's, their exponents will be increasing. So now we have plus, and then we have 4 times negative 2 to the power of 1 times g to the power of 3. Why are we writing g to the power of 3? Because we're decreasing these exponents, right? So this is 4, now it becomes 3. Conversely, this negative 2, his exponents are going to be increasing. So now we have plus, and then you have 6. I didn't leave enough space, but that's okay. See if I can squeeze it there. Negative 2 to the power of 2 times g squared, okay, plus, and then we have 4 times negative 2 to the power of 3 times g to the power of 1, right? Because the g, again, the g's are decreasing and the negative 2's are increasing. Then finally we have 1 times negative 2, trying to fit that there, negative 2 to the power of 4, g to the power of 0. Okay, so I have already expanded this out. Now I just have to simplify. So negative 2 to the power of 0 is 1 times 1 is 1, so your first term is g to the 4th. And then you're going to bring down a plus sign. And then this, actually, I'm not going to bring down this plus sign. I'll tell you why right now. Because some of these might be negative, right? So you don't, it's kind of annoying to write plus and negative. So you can, I mean, mathematically it's fine, but it just looks more aesthetically pleasing if you put a minus sign, right? So this is 4, and then this is negative 2 to the power of 1 times 4 is negative 8g cubed. So we get minus 8g cubed. Okay, then over here we have negative 2 squared, which is 4, times 6 is 24. So we get plus 24g squared. And then this one's going to be a minus, right? So minus negative 2 cubed is negative 8 times 4 is negative 32. So that's minus 32g, because it's to the power of 1. And then plus 1 times, so negative 2 to the power of 4 is going to be 16. G to the power of 0 is 1, so it just goes away, right? And this is our fully expanded polynomial. So we get g to the 4th minus 8g cubed plus 24g squared minus 32g plus 16. All right, so that's how you do that one. Let's see if we get a difficult one here. Look at number 3 is interesting. Let's look at 3. So number 3 has 3x, minus, it's 3x minus 4 cubed. Yeah, again, you have to be very careful. When you're working with Pascal's triangle, remember that the binomial is, you write it like this, right? It's a plus b to the power of n. So that means that our a is 3x. So you have to be extremely careful with this. They're going to try and trick you by writing these two things there. So you're treating it as one entity, right? It's one unit. And then, of course, this is like saying plus negative 4. So again, we're going to be doing the same kind of negative, right, that we were doing before. Okay, so the first thing I'm going to do is look at the triangle. So let's go to the triangle. And our exponent here is 3. So that's when n equals 3. As you can see, when n equals 3, our coefficients are 1, 3, 3, 1. Okay, so I'm going to go ahead and put an equal sign here. We're going to start writing the coefficients. So that's 1. Put a space 3, put a space 3, and then 1. Okay, now we're going to go ahead and copy down the terms. So the first one, I'll go ahead and write, I'm going to write the second one first. You don't have to, but I like doing that because the letter's on the left side. So what does matter though is that this first term always starts with the biggest, with this exponent, and then decreases. The second term starts with 0 and then increases up until you get to the number that's written here. So we have negative 4 to the power of 0 times, and I'm using parentheses, you have to be very careful with this. That's 3x in parentheses, because this is your a, right? So that has to be in parentheses. And that's the leading numbers cubed, right? So I put a cubed there. Okay, then I have plus 3, again, negative 4 to the power of 1 times 3x squared. Why? Because these guys are going down, right? And then these are going up. Okay. I don't know if you can see that. Let me zoom in a bit. Okay. So then we have plus, and then this one is going to be 3 times negative 4. This time for the negative 4, we're going to put a squared. Again, because these are increasing, right? 0, 1, 2. And then for the 3x, we're going to write the 3x is decreasing, right? So cubed, squared, now it's to the power of 1, plus, and then the leading coefficient there is 1 times negative 4 cubed, because that one's increasing, times 3x to the power of 0. Okay. So we can go ahead and simplify this. We've already expanded it. So negative 4 to the power of 0 is 1 times 1 is 1. Now be careful here. This is saying 3x in parentheses cubed. So that's 3 times 3 times 3, which is 27x cubed. So this is 27x cubed minus, here we have negative 4 to the power of 1. That's negative 4 times 3 is 12. And then 3 times 3 is 9. And then 9 times 12 is 108. So you get minus 108. X squared. Okay. So then for the next one, we have negative 4 squared, which is 16. And 16 times 3 is 48. And then this is times 3x to the power of 1, right? So 3 to the power of 1 is 3. And we have 48 times 3, which is going to be 144. So this is plus 144. X to the power of 1. You don't have to write x to the power of 1, so I'm just leaving it like that. Let me try and clear this. It looks better. Okay. So you got that, and then we have plus, and then this is negative 4 cubed, which is negative 4 times negative 4. That's positive 16 times negative 4 is negative 64. So actually it's going to be a minus. We get minus 64. Now this is 3x to the power of 0, which is just 1. So he simplifies, cancels out. So you just get that. You're done with that one. All right, cool. Now let's go ahead and look at the other ones that you had a question on. Let's see. Use Pascal's triangle. Oh, so it's the same thing again. All right. So this one is 14a. I'm gonna do this a little quickly. All right. So we have 6x minus 2. I'll write it as plus negative 2 cubed. So again, we're gonna be using the same coefficients because it's n equals 3. So you go to your triangle, n equals 3, that's 1, 3, 3, 1. So let's go ahead and write that. 1 space 3 space 3 space 1. Okay. Now we can write our terms. So the first one is going to be, I'm going to put the second one in, I'm going to put it in front. Like I said, you don't have to. The teacher might not even do that. I'm just doing it because the x is in the back, so it just looks nicer, right? So just always remember that this one starts with 0. This one starts with whatever the number is here for the exponents, right? So that's 0. And then we have 6x, so multiplied by 6x to the power of 3, plus, and then now we have 3 times negative 2 to the power of 1 times 6x squared plus 3 times negative 2 squared. It's 0, 1, 2, right? So it's going up. And then here you have 6x to the power of 1, right, which is just 6x there. So I'll put a 1 just so you can see it there. And then, of course, we have 1 times negative 2 to the power of 3 times 6x to the power of 0. All right, good, good. So now we just simplify the math. So it's negative 2 to the power of 0 is 1. 6 cubed is 6 times 6 is 36, and 36 times 6 is what, 343? Wait, 6 times 6 is that 343? Yeah, check that out. Something tells me that this one, right? Hold on. This one is, yeah, 216, that's what it was. So here we get 216 x cubed. And then we have plus negative, right? So that's 3 times negative 2 is negative 6. And then this is 6 times 6, which is 36. So we do negative 6 times, should be 216, right? Yeah. So we get negative 216 here. So minus 216 x squared. And then over here we have plus, and then this is negative 2 squared, which is 4, times 3 is 12, and 12 times 6 is 72. Yeah. So this is 72x. And then finally over here, this is negative 2 cubed is negative 8 times 1 is negative 8, and then this is just 1, right? Because 6x to the power of 0, all of it goes away. It's just 1. So then you have this guy. And we're done with that one. Now we're going to do 15b. I mean, sorry, 14b. Okay. Let's see what we got here. And this is going to be yz plus 2 to the power of 5. Okay. Alright, so the first thing I'm going to do is go ahead and look at the triangle, which is up here. Notice this is n equals 4, so we need to make a new row for n equals 5. So a new row. So that'd be 1, and then 1 plus 4 is 5, and then 4 plus 6 is 10, 10, 4 plus 1 is 5, and then 1. So, ooh, that's a long one. So we have 1, 5, 10, 10, 5, 1. Those are the coefficients. So I'm going to leave a lot of space here. So that'll be 1 space, 5 space, 10 space, 10. There should be enough space. Okay. All right. Now we're going to do the same thing. Of course, be careful. This is yz. We're going to put that, you don't have to put in parentheses, but just like we've been doing before, we're treating that as a. So we're going to be writing them in parentheses when we put our terms over here. So let's go ahead and start with the second one. So that's times 2. And remember the second one's going to start with 0, right? So it's 2 to the power of 0. And then times yz in parentheses to the power of 5. Okay. Plus 5 times 2 to the power of 1 times yz to the power of 4. 10 times 2 to the power of 2 times yz to the power of 3. Remember, those are decreasing there. And then plus, and then this is 10 times 2 to the power of 3 times yz to the power of 2. Okay, plus, and then 5 times 2 to the power of 4 times yz to the power of 1. Okay, cool. And then finally we have 1 times 2 to the power of 5 times yz to the power of 0. Okay, so we wrote it out. Now we just have to multiply things. So here we have 1 times 2. So 2 to the power of 0 is 1, right? Times 1 is 1. So here we just have y to the power of 5, z to the power of 5. Be careful. this, you distribute the exponents right. So that's y to the power 5, z to the power 5. And then we have plus, this is 2 to the power 1 is 2, times 5 is 10, so this is 10. Y to the power 4 is z to the power 4. Plus, 2 squared is 4 times 10 is 40. Y cubed is z cubed. Okay. Plus, 2 to the power of 3 is 8 times 10 is 80. So that's 80, and then you have y squared, z squared, plus 2 to the power of 4 is 16, and 16 times 5 is 80. So we get 80 again here. This time it's yz, because it's to the power of 1. And then finally, 2 to the power of 5 is going to be 32 times, well, yz to the power of 0 is 1, right? So it's just that. It's just 32. All right, cool. And then that's your answer for this once you do that. All right, cool. Awesome.